So of late, I'm spending a lot of time focusing on memory and knowledge modeling. Knowledge modeling is not what I'm going to talk about in this recording. We're going to talk about memory and the like whenever I'm not doing something, uh, some other thing, right? I'll think about memory and knowledge modeling. And the consequences of this is sometimes I'll miss an exit while driving, thinking about memory. Now, memory is like if you have followed my previous blogs and videos, you'll see that I talk about memory a lot because I think memory is one critical component of GenAI based application to improve consistency, reduce latency, and improve accuracy. We need to think about memory architecture to be able to have more efficiencies or extract more efficiencies out of LLM based application. And this is not coming just out of the air. This thought or this concept has come to me after I have read many of the books related to neuroscience, and I followed David Eagleman a lot. So the way he explained how human brain works helped me to conceptualize some of this and then solutionize that as well, right? And the reason why our brain works so efficiently, right? It works on 5 watts of energy, and it's just, I think, 3 to 5 grams or 3 to 5 pounds of the brain mass works on 5 watt of energy because our brain is a memory engine, not a compute engine. Now, when as a kid, I used to think the brain has only limited storage for memory. So if I learned something today, tomorrow I learned something new, the old learning gets kicked off the brain, but it never happened. So I was surprised, right? How does brain keeps memory of so many things, right? And then when I started understanding how the brain memorizes or how the memory works, found out that human memory is associative in nature. We to memorize something, we associate that with something else, right? Which probably is an association of uh, another thing or something that is easier to pronounce, right? I associate something to a word like that. And to give an example, when we were kids, we all know, and I'll show this, we probably all know the term bodmas, right? Now, bodmas, I come from like I'm a Bengali, so in Bengali, badmas is actually a word in our vocabulary, which I think in English probably it will mean naughty, right? So badmash is a word that I know. Right? So when we were kids, we were taught about operations, mathematical operations, right? Like add, subtract, multiply, divide, square, right? So when we have an operations like this, I cannot just do multiplication first, right? So I'll have to do the bracket first, right? Then I'll have to do the order of operations like into addition, multiplication and all. But how do I remember that, right? That's where the term bodmas came in, and it was very easy to remember because it's part of my vocabulary. Now, whenever I see this, I can remember, okay, B is bracket, O is order, D is divide, M is multiplication, A is addition, S is subtraction. It is very, very easy for me now to remember this by associating it with a vocabulary that I know, right? There is one more example, and I think only Bengalis will understand that, but I'll still say that. So the word of psychology, right? Psychology was very difficult for me to remember the pronunciation, remember the spelling of it, right? So when we were kids, we said, okay, how do you remember it? So psychology, so we said PSY is Pishi. Pishi is like aunt in our language, in Bengali language. Kolo is cholo, cholo is go, Pishi cholo, and GY is jai, like go. So jai is a Bengali word for go, right? So we break it down into the vocabulary that I can remember, and it was very easy to associate that with that and then write it, right? So the reason for me to give these examples is that human memory and is associative in nature. How and if the human memory is efficient because of this association, how can I implement that in language models, right? So the language models, the memory of the language model becomes efficient. I'll not say language model because this memory is kind of an external memory I'm talking about. You equip the LLM based application with the memory, but how do I create an associative memory for a LLM based application? And that is what, like, one of the things that I was thinking and trying out is what I'm going to show you today, right? So let me go back to my code where I'll show like how I'm thinking of the implementation part, right? So what I have done in this code is just a very basic question answer in a loop. I'll ask a question, a LLM chain. This is the chain that I have. The chain is a prompt, answer the question. I'll ask a question, the chain will answer the question, right? But what I'm also doing is, once I get the response, the question and the response, I am using a Grok model to and Grok model and a LLM graph transformer. This is a wrapper from LangChain, and I'll show you what it does to extract the association from the question and the answer and store it in a Neo4j graph database. Now, what does this do, right? So I'll just quickly show that to you, and then we'll see how it works, right? So when I give the question, and so I create an LLM transformer by instantiating the LLM graph transformer. This is the LLM that I'm passing. This LLM is the Grok model. Where did I code it? Okay, this is the CAD Grok, right? This is LangChain's abstraction on Grok. Now, I'm using Mixtel here, but if you are not familiar with Grok, Grok is popularizing the inference engine LPU, language processing unit, which is much, much, much faster than GPU. And that is the reason I'm using Grok here, because I want, as soon as I get the response in the memory, I want to store it in memory quickly, right? So if I used normal GPU OpenAI inference engine, it takes time, right? So here I'm using a model from the Grok Cloud using LLM graph transformer to extract the nodes and the relationships from the question and answer, right? Now, how it works is, if I go to LLM graph transformer, the prompt, it's through a prompt what it is doing. Let me show the prompt here. So this is the prompt. So if I look at the prompt, okay. So you are a top tier algorithm designed for extracting information in structured formats to build a knowledge graph. Try to capture as much information from the text as possible without sacrificing accuracy. Do not add any information. Now it is telling how to extract the nodes out of the text, how to label the nodes, how to, there is a place where it also does the, so co-reference resolution. There is a Okay, so here it is also creating the relationships. Yeah, relationships. This is what I find, right? Relationships represent connection between entities or concepts. So through this prompt technique, I'm trying to identify the important entities and relationships in my question and answer. And then what it does is once it gets so when I do LLM transfer to convert to graph, after it creates the nodes and the relationships, I add those node relationships into a knowledge graph like Neo4j, right? And to demonstrate that, I created this conversational chat. So let me run it and then show you how it works, right? So let me start. And at the same time, when it is starting, let me go to my knowledge graph. Right now, it is empty. There is nothing, right? So let me start asking some question. Where is Taj Mahal? Right? So now I'm using GPT-4 to answer it. Now very fast, right? The grok actually now created the associative memory. If I go here, if I run the graph again, you see, this was the question that I asked. It has started Taj Mahal, then saying located in Agra. Agra is located in India, right? It created that association. Let me continue to ask some question. Is Taj Mahal a monument? Right. Let's see what happens now. Yes, Taj Mahal is a monument. So let's see if I run it now. So I have another question that has come in. And here, so whatever answer it gave me, that it is a white marble mausoleum located in Agra and was built by Mughal Shah Jahan, right? And Taj Mahal is a monument. It created those associations also. So it was created for Mumtaz Mahal, Mughal Emperor Shah Jahan built it. Let me see if I can increase the, how do I increase the, okay, let's see if it works like this. Yep. Okay. So yeah, Mughal Emperor created it for spouse Mumtaz Mahal. The other is it mentions Taj Mahal. The question mentions Taj Mahal, mentions Agra, like whatever I the nodes I had, right? It associated that question with those nodes also. And what is this? UNESCO World Heritage Site, right? It mentions UNESCO World Heritage Site. So the answer, from the answer, it is getting those association, right? And creating those association, right? Now let me actually give it, now let me talk about a different concept now, right? So let me talk about color of mango. Right? What is the color of mango? This time I'll have a different memory, right? So I should see another memory that has been built with mango. So this is the question, mentions mango, right? Mango has color, right? So mango has the color. So one thing, and this is something that it needs to improve. So in the answer, it also said that um, depending on variety and ripeness, but it is typically a combination green, yellow, orange. It did not capture the color. And that is probably because so when I was using GPT-4 for this, right, I was getting the color, but it's maybe because Mixtral not as powerful, the 8's, the MOE, right? 8 is like the MOE and the 7B is the size of the model. It may not be as powerful as GPT-4, right? But I was expecting that. But anyway, like that doesn't matter for this recording because I wanted to show that concept. Now I'll ask another question. Is mango sweet? Yes, mangoes are typically sweet instead. Let's see if it associated that. Yes. So now the association is on taste, right? So mango has taste, which is taste is sweet, right? So it is building that association. Let me ask, is chocolate sweet? And see if what happens to that. Yes, chocolate is typically considered to be sweet due to its high sugar content. Now, if you see the memory that I had earlier, and that is the beauty of this that I found out. Now, sweet, it associated chocolate with sweet, right? Now, what this is what actually I wanted to showcase to see like how, as a conversation is going on, I can build this association, right? Now, if I can build this association, this associative memory, in future, I'm not just confined to these questions. This, like how humans, we can deduce patterns from pattern out of patterns, this associative memory can help me to answer some additional questions also. For example, I say, where is Agra located? I know now because my associated memory, I know that Agra is located in Uttar Pradesh in India, right? I can say, okay, are the tests of mango and chocolate same, right? I can deduce it from right here, right? So that is the thought process that I have on memory. Unfortunately, I have not seen anyone thinking about this associated memory like this, right? This is one of the things, like I feel like we need to think about memory in this way also, like through an associative memory. But I also agree that in human, memory is a subsystem, right? So associative memory can be one part, but there are other parts of memory also. I can have a semantic memory and an entity memory and all, but associative memory is also very important. And as I say, like I have not seen anybody actually thinking in this lines or talking about this. And in my previous blog, you'll say that memory needs a graph store. This is the reason I think memory needs a graph store, because graph stores like Neo4j or other type of graph databases are very or are compatible to store this type of associations. It is scalable, it is adaptable. Uh, new memories can, the new memory associations can be easily inserted or updated if I have a graph store. So that's all for today's. That's all that I wanted to talk today about memory. I today and the weekends, like I spend time to explore such things. So I'll continue to explore this space and come up with some more ideas. And I would love to hear uh, some feedback, how people think from their experience, right? And as I say, it takes a village to make an LLM work or to learn memory, right? And it is through the intelligence of the mass, we can make this better. Thank you.